Hello students, how are you all? So we are back with the simple machines idea. So first of all, we have to check how many types of simple machines are there. So there are 6 types of simple machines that you can see: lever, inclined plane, winch, screw, pulley, and wheel and axle. So one by one we will see all this. So first of all, coming to lever. So from seesaw to any kind of rod is known as lever. How they work actually? First of all, I'm taking one rod over here. So as you can see, this is one rod. And in here, I'm putting a triangular object. So as you can see, if you try to pull this part up, this part will go down, because this rotation is now getting possible by taking this center, because this body will rotate like this with this center, right? So this center is known as fulcrum. We can also refer this with capital F. So this center is known as fulcrum. Acha, how they actually react, or how does it work? It's actually provide that along which center the whole lever will work or rotate. So if you try to put it in upward, then this one will go downward. Exactly the idea as seesaw, as you can see over there in this image 5.6 figure. Okay. So also there are two more things that we have already discussed in our previous video, that is effort and load. What I told you about effort you will always provide, right? So you are hammering something, that means you are first giving some force to that hammer. So that is known as effort. So in here you are putting this side upward. So the effort is actually working in this part. And also due to that the machine is working in this part. So that is the work done by that machine, which is known as load. So effort is also referred as, in here it is load. So we got 3 positions of load, fulcrum and effort or lever. Now these positions can be vary, and according to those variation of position, we classified all this lever into 3 parts, that is class 1 lever, class 2 lever and class 3 lever. So let me show you what are effort arm and load arm. So from here to here, as you can see, this effort is in right side. So we can say this is effort arm. That is nothing but the length from the fulcrum to the point of effort. Also, you can predict, that is, this is known as load arm, from the fulcrum to the point of load. Simple one. Okay, but this will give you one idea about load and effort. We already have discussed about mechanical advantage is equal to load by effort, right? Now this ratio will be also equal to effort arm by load arm. As you can see, these are inversely proportional. That means totally reciprocal of this one, right? If this is load by effort, then always remember this one is totally reciprocal. Effort arm by load arm. And very important part is coming from here, that is, if you cross multiply only this part, you will get load into load arm, that should be equal to effort into effort arm. So remember all these formulas. We will do some sums regarding these all formulas at the last of this video. So I hope the idea is clear about this one. Now moving to class 1 lever. All you have to remember for all this lever, that is the positions. And as I show you over here, that is the class 1 lever. In this case, you can see that fulcrum will be in middle, load will be in this side, and effort also will be in this side. So as same as that. So this is one simple machine with class 1 lever. Okay, so now coming to the example of that. Obviously, you can see that the pillars and the pillars of the class 1 lever, and all kind of, even seesaw is the class 1 lever, so we can give the idea about that. So always remember that the fulcrum lies between the load and the effort. That is the classification of class 1. Coming to class 2 lever, what is that? This time the fulcrum will be stay at the extreme left. So in here the fulcrum it is, and due to that the load will be work over here and effort you have to put it in this right hand side. So how does it actually work? Suppose this is a fulcrum, so we need a point to rotate, and for load we are putting some object over here and you are trying to pull it up, right? So also, as you can see, all these terms like wheelbarrow and also for the bottle opener, these are known as class 2 lever. All you have to say that the fulcrum and effort will be in two opposite ends, or you can say also like that the load will be lies between fulcrum and effort. So that is all about class 2 lever. Always remember that you have to read the examples of class 2, class 1, class 3 levers, as well as the positions are important of fulcrum, the load and the effort. Coming to class 3 levers, this time the effort will be middle of fulcrum and load. So as you can see, this is the point of rotation, which means fulcrum. I'm putting some object over here, that means the load is acting here and the effort is applied over here. So as you can see, the effort is actually lies between fulcrum and load. So for example, you can take the hockey stick. As you can see, let me discuss it over here. That is hockey stick. First of all, you grab it over here. That means this is your effort. Okay. The point of rotation, that is this point, because we switch that hockey or golf stick like this. So the point of rotation is here. So this is our fulcrum, right? And what is the load part? That is, you are hitting this portion with the ball, so it will be the load part. I hope the idea is clear right now about the fulcrum, effort and load. Okay, so that is all for this video. We will meet in the next one and we will do some sums over there.